Okay, we are here correcting section 3.2. The questions that were assigned from your MathLinks textbook, there's 1 to 20, I guess 4 to 20 something. 21, I guess, is what we did. We skipped a couple, but that's generally what we have to do. We're starting here at question 5, actually, and it says write each expression as a single power, then evaluate. So with the first question, we actually have two powers that have the same base, and we're multiplying together. The rule is keep the base and add your exponents to get a final answer of 4 to the 7. When we evaluate that, 4 times 4 times 4 times 4 times 4 times 4 times 4, it's easier to go 4 to the exponent of 7, which is 16,384. Your second question, again, multiplying two powers that have the same base. Keep the base and add your exponents. 7 to the power of 6, which is 7 times 7 times 7 times 7 times 7 times 7. 7 to the exponent of 6 is 117,649. And finally, C, the brackets around the base of negative 3 mean that is used in repeated multiplication. That is the base. So negative 3, 5 plus 2 will be negative 3 to the exponent of 7. When you have a negative base to an odd exponent, what type of answer will you always have? Negative, correct. So negative 3 to the exponent of 7. I didn't put a negative 3 base in, but I know it's negative. It's negative 2,187. Question 6 says rewrite each expression, so we're doing the exact same thing again. Keep the base, add your exponents. 5 to the exponent of 5, which I think I know is 3125. I think I know that one. Next one, negative 6 is your base. Add your exponents, 3 plus 3. You get negative 6 to the exponent of 6. Will my answer be positive or negative? Positive. So this time I'm going to put a negative 6 to the exponent of 6. 46,656. 46,000. What was it again? My memory's terrible. 656. And finally, your last one, 8, 1 plus 2 is 8 to the 3. 8 times 8 is 64, and 64 times 8 is 512. So in standard form, 512. Question 7, rewrite as the product of two powers. So when we think about this, it's saying that that's one power and that's the other. We're multiplying together because they're in brackets. So therefore, 4 cubed multiplied by 4 to the 4 as a single power is 4 to the exponent of 7. It doesn't say simplify it to standard form, just as a single power. Your next one, we have 2 multiplied by itself 5 times and 2 multiplied by itself twice. 2 to the exponent of 5 multiplied by 2 to the exponent of 7. Add those, you get 2 to the exponent of 7 as a power. And finally, 9 to the exponent of 4, right here, multiplied by 9 to the exponent of 7. Add your exponents, you get 9 to the exponent of 11 in exponential form, which actually is a really big number. If we actually did 9, if we were solving it, 9 to the exponent of 11, it's actually 31,381,000, which is a pretty big stinking number. Question 8 says, write the following expression in repeated multiplication form, and then as a single power. So if I think about these three separate powers, then the first one is 3 times 3. I'll keep it in brackets. Multiplied by 3 times 3 times 3, which is the second power. Multiplied by 3 times 3 times 3 times 3. When we think about that, it's just a string of really 9 3's multiplied together, so it's really 3 multiplied by itself 9 times as a single power. Question 9, now we're using our second law, Andrew, of our exponents, which says when dividing powers that have the same base, you can keep your power and subtract your exponents to give you a final answer as a power of 5 squared, which we all know is not 10, but 25. And the second one, keep your base, subtract your exponents. We get 3 to the exponent of 4. Since 3 times 3 is 9, 3 times itself 4 times will be double 9, which is 81. And finally, keep the base, subtract your exponents. negative 4 to the exponent of 4. 4 times 4 is 16. 16 times 16 is 256. Will that be a positive or negative? Negative. If I wrote the question like this is actually an interesting one, right? This is an interesting one because pay attention. Let's pretend I didn't have brackets around it. What would this simplify to as a number? Positive or negative number? It's negative. So it would actually be negative something. It's negative 4 to the exponent of 6, which is a big number. Let's just see. 4 to the exponent of 6 is 4,096. So if we think about it, this one would have been negative 4,096, correct? Divided by, would this one be positive or negative? It's still going to be negative because it's the opposite of 4 squared, which is negative 16. Let's use our grade 8 sign rules. Will that answer be positive or negative? Interesting, eh? So without brackets, we actually can change the sign of it because we're dealing with opposites of both of those answers. So without brackets, it would have been a positive 256 quotient or answer. Yeah. Question 11. We have 6 multiplied by itself 4 times, or 6 exponent 4, divided by 6 exponent 3. Keep the base, subtract your exponents. I get 60 to the exponent of 1, which is just 6, but it doesn't say to evaluate. The next one, we have 3 to the exponent of 8, divided by 3 to the exponent of 2. Keep the base, subtract your exponents. You get 3 to the exponent of 6 as a single power. And finally, your last one, 1, 2, 3, 4, 5, 6, 7. 5 to the exponent of 7, divided by 5 to the exponent of what number? There's nothing written there. What's the exponent? Just 1. Keep the base, subtract your exponents. Exponentially speaking, your answer is 5 to the exponent of 6 as a single power. Trucking right along, we have number 12. Write the following expression as the division of 2 powers. So if we think about a power divided by a power, and the work I showed was negative 5, 7, take away 2, I would end up with a negative 5 to the exponent of 5 as an answer. But really what the question is what was this original expression if this is the work I did? And the answer is I had negative 5 in brackets to the exponent of 7 divided by negative 5 in brackets to the exponent of 2. That was my original expression before I simplified it to become negative 5 in brackets to 7 minus 2. So this is your answer. Without the squares, you don't need the squares there. Question 14, right? We're using law 3 now, powers to exponents. The rule is, if you think about it, it's 3 squared multiplied by itself 4 times, which would have been this. But the law says when you have a power to an exponent, keep your base and multiply your exponents to get 3 to the exponent of 8, which makes sense because this is 3 to the exponent of 8, isn't it? And evaluate. So because it says evaluate, 3 to the exponent of 8 is going to be a pretty big number. 6561. 6561 in standard form. Question B is an example of law 4, where we have the product of 2 numbers in brackets to an exponent. And what the exponent law says is we can reallocate that exponent to both parts of our product, meaning we can write it as 7 to the exponent of 4 multiplied by negative 3 to the power of 4. Once we have that, we can evaluate it using BEDMAS. 7 to the exponent of 4 is 2401. Negative 3 to the exponent of 4 I actually know is being positive 81, so divided by 81. Take this number we already have with the calculator, divide it by 81. Is that right? Did I make a mistake? That can't be right. I must have made a mistake somewhere. Did I make a mistake? Oh, it's multiplication. Haha. See, I made a mistake. So, 2401 multiplied by 81 equals 194, 481 in standard form. And finally, the last one, I want you to keep in mind and make a note of this on your paper because a lot of you probably didn't rewrite it, but this is the same thing. Just make a note just to remind your brain that these 2 questions are the same thing. And as such, If I keep it the way it was, this exponent of 4 is allocated to both numerator and denominator. If I kept it the other way, it's added to both parts here regardless. So I'm going to end up with either 5 to the exponent of 4 over 6 to the exponent of 4, or 5 to the exponent of 4 divided by 6 to the exponent of 4. Both mean the same thing. When I take 5 to the exponent of 4, I get 625. When I get 6 to the exponent of 4, I get 1296. When I simplify that from fraction form to decimal form, I divide the numerator by the denominator, 625 divided by 1296. Did I make a mistake again? Where? Is that right? Okay. 0.4822. And since I'm rounding it, I'm going to change that from an equal sign to an approximately equal sign because I did round. Same thing would happen here if you had 625 divided by 1296. You still end up with approximately that answer there. Now, alternatively, instead of changing it to a decimal, could we have just kept it as a fraction? Could we have just said, you know what, a decimal and a fraction are the same thing. What's a better one? The actual fraction is better because it's the exact answer it is, right? The decimal is just an approximation because we rounded. So in this case, if I had a choice between an approximation of a decimal or a fraction, I would simply keep it as a fraction. Question 16, write the following expression of the power raised to an exponent. So we have 2 to the exponent of 2 multiplied by itself 4 times, or 2 to the exponent of 2 multiplied by 2 to the exponent of 2 multiplied by 2 to the exponent of 2 multiplied by the 2, which really means 2 to the exponent of 2 multiplied by itself 4 times. So our answer is 2 exponent 2 in brackets, exponent of 4 outside the brackets because it's multiplied by itself 4 times. Question 17 says copy and complete the table. In repeated multiplication, since this is going to be, I'm just going to work down here. So 2 times negative 5 cubed. If I allocate it here and here, it's going to be 2 cubed times negative 5 cubed, which in repeated multiplication, I'll use a red marker, is 2 times 2 times 2 multiplied by negative 5 times negative 5 times negative 5. Would you agree with that? Or 2 cubed multiplied by negative 5 cubed. In the second one, it gives us 9 times 8 times 9 times 8, which will be 9 times 8 in brackets with an exponent of 2 outside the brackets. I mean, 9 times 8 is multiplied by itself 2 times. And finally, in repeated multiplication would be 2/3 times 2/3 times 2/3 times 2/3, or 2 divided by 3 times 2 divided by 3, or 2 to the exponent of 4 divided by 3 to the exponent of 4. Question 18. Evaluate 2 to the exponent of 0 and use a pattern to justify your answer. Well, if you look at your notes, you actually have this answer here. If I did 2 to the 5, 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, and you know what, just for poops and giggles, I'm going to go 2 to the negative 1 and 2 to the negative 2. If I think about what 2 to the 5 is as standard form, 2, 4, 8, 16, 32. 2 to the 4 is 2 times 2 times 2, which is 16. 2 cubed is 8. What do we notice with the pattern here as we go down here in standard form? Emma, what's the pattern here? You don't see the pattern between 32, 16, 16, 8, 18, 8 to 4. You don't see the pattern? Abby, do you see it? What is the pattern? It's half every time, right? 2 to the 1 is equal to 2. So therefore, based solely on the pattern, what is 2 to the 0 based on the pattern? 2 to the 1 is just 1, half of 2. And here's an interesting question. What's 2 to the exponent of negative 1 going to be then? Negative, or just not negative, half of 1. What's half of 1? 0.5. What should 0 or 2 to the negative 2 be? What's half of a half? No, what's half of a half? 0.25. Let's just double check our answer. Let's just use a calculator and see if that's worked. 2 to the exponent of negative 2, right? Okay, anyone really brilliant? What's 2 to the exponent of negative 3? 0.125, half of a quarter, 12.5 cents, and so on and so forth, right? Will a negative exponent ever have a negative value? No, it'll always just be half. It's kind of like that idea of walking towards a wall. If you walk half the distance towards the wall, and then you watch half of that new distance towards the wall, and then you walk half of that distance towards the wall, you will never actually get to the wall. Think of it. I mean, because every time you're only going half of the distance to your goal, eventually your shoes are going to eventually collide, but you're really not going that distance, right? So, but you get what I mean. Question 19 is a great example of this. Make a note of that. That's a great thing to write down. Negative 4 to the power of 0 does not equal. However, watch this one. This should blow your minds. Okay, make a note of that on your paper right now. Everybody's paper. These are not equal. In this case, this is the opposite of 4 to the 0. And this is negative 4 as a base to the exponent of 0. That's true. This one here is still the opposite of 4 to the 0. This one here is also the same thing, the opposite of 4 to the 0. The reason why it's different is where the exponent is. Outside the brackets versus inside the brackets, right? It's a different thing. Thank you, Tim. Thank you, Tim. I know you do. So, because that's true, let's look at these questions here. What is this value? It says the opposite of 4 to the 0. Since 4 to the 0 is 1, then the opposite of 4 to the 0 is negative 1. Is this negative 4 base, or is this the opposite of 4 to the 0? It is the opposite of 4 to the 0, and I know that because my exponent of 0, Abby, is not outside the brackets. So this will be a negative 1. What will this be? Also a negative 1. And this will be a negative 1. The product of those three together is still a negative 1. Question 21. Express each of the following as a single power. Power to an exponent, keep the base, multiply your exponents. Now we have multiplication of two powers that have the same base. Keep your base, add your exponents. And we have the final answer as a single power of 3 to the power of 11. What operation is being implied here? That's multiplication. It's two powers next to each other with nothing in between, which means multiplication. If I rewrote this, I could actually write it like this. Negative 4, the exponent of 2, multiplied by negative 4 to the exponent of 4, divided by negative 4 to the exponent of 3. That's the same question, isn't it? Right. We'll simplify what's the top part going to be here? Keep the base, add your exponents, you get 6. Keep your base, subtract your exponents to get a final answer of negative 4 cubed. Question 22, Jenny. Jenny was asked to complete the following exercise. Write the express. Can anyone else say Jenny without saying it like Forrest Gump, or is that just me? Jenny. Evaluates this expression as the power. That's the product of two powers in express. Okay. So we have 7 multiplied by itself 5 times, which is 7 to the 5th, multiplied by 7 to the exponent of 3, which as a single power, since we're going to keep the base and add the exponents, will be 7 to the 8th. What mistake did Jenny make? Jenny was not listening in math class, because instead of adding her exponents, like she should have done here, Jenny multiplied the exponents to get the wrong answer of 7 to the 15th, as opposed to 7 to the exponent of 8. Question 23, is this the last one? It says write 3 different products. Each product must be equal of 2 powers and it'd be equal to 4 to the 5th. So, okay. So it has to be products, which means multiplication. So I'm going to start with the one that most of you probably had. 4 squared times 4 to the cubed. Another one you probably had is 4 to the 1 times 4 to the 4 to give you 4 to the 5. Another one is 4 to the 0 times 4 to the 5 is 4 to the 5. And those are the only 3 non-negative ones. You could also have 4 to the negative 2 times 4 to the 7 is 4 to the 5, which is kind of interesting. But if you did negative exponents, you're way ahead of the game.